It's a pleasure for me to introduce a guy that has gone from carpentry, being a carpenter, to one of the first wood engineers in Switzerland. He has some 20 plus years of management and development experience in a company dealing with 3D CAD/CAM software. He has since a couple of years the function of professor for timber construction and BIM at the Bern University of Applied Science. His activities in research includes digital issues, and also he has an interest in this sense in new opportunities with hardwood, especially beech. He has also founded and organized a number of wood conferences all over the world, I would say, or at least ranging from the Czech Republic all the way down to South Africa. And it is a very big pleasure for me to introduce Thomas Rohner.
Ladies and gentlemen, welcome to Sweden. I know, the other way around, but for me, you are used to live in Sweden, me not. So I'm coming from Switzerland, that's a little bit south. So I'm also a diving teacher, a diving instructor. I'm driving around with my friends, my Harley friends, and when I got 50, I did north face of Eiger in a winter climb. So there's not a lot I haven't done yet, and all these experience I will give to my students by now, and teaching them all different techniques of life. So let's talk a little bit about BIM. What is BIM? If you ask a 10-person what is BIM, you get at least 12 different answers back, because for the ones BIM means 3D models, for the others is a method of holistic planning, for the other ones is just an exchange of digital data. It depends a little bit. Let's see what history is. The history from these hand drawing lines with a lot of human interpretation, and it didn't change when we get into a digital line, 2D CAD, for example. There was still a huge part of human interpretation, and it changed when we get into volumes and surfaces, shapes and forms, and when we come to digital objects and components. So that means the way of interpretation is getting smaller and smaller, even by all these materials, if you have properties, relations, and machine interpretations. So the danger of making mistakes got smaller and smaller and smaller. So this way from 2D to 3D was a long way, still an ongoing process, especially in the architecture, but there are more Ds, there are even 7 Ds, like the 3D model with the time scheduling is a 4D, and with the estimations, that means with the costs, it's a 5D. With sustainability, like energy, like LED, like materials, whatever, is a 6D, and facility management is a 7D. So we have a lot to do in our process, or in our ongoing process, because 3D is used in wooden construction. Since this was one of my first drawings, is a church in Italy. In 1990, we were able to make 3D models, but that's not BIM. That's not BIM at all. In BIM, we are talking about the whole circle, from design, planning, implementation, to the management and the conversion or revitalization, as we say in now. But when does it start? When will this BIM process start? It starts really, really early. It starts at least at the strategic planning, and it ends up end of life of the building. This is BIM. So it is just a point of view all over the building from the first idea to the end of life. And what are we trying to do with this virtualization of the building industry? We are simulating. We want to simulate the whole building process virtually. Cradle to cradle, as I wrote there, cradle to cradle in the whole, that means the whole process. But what is the target of all this? We know the error rate in the building industry, probably in Sweden, is not as high as in Switzerland. In Switzerland, we are talking about 18%. 18% of error rate. So that means our buildings could be 18% less costs if we wouldn't make any mistakes. I mean, this is an illusion. No mistakes. That's not possible. But there is a big potential. And there is another thing, this repetition effect, this repeat effect of the building industry. So we make a building first on a digital way, on our digital model, and then we do it the second time physically. So there is also a huge potential inside this. I mean, once ago, all architects, they made models. They made physical models, like here, heliotrope. Heliotrope, helio means the sun, and trope means turn. So you see, this house has one side totally glass, and the other side is totally closed. So you can drive around with the sun in wintertime or in summertime. So nice little thing we did in about 3 of these. But the digital model, let's call him the digital twin. We are trying to simulate, we're trying to calculate, we try everything on this digital twin. And it's not easier to make a digital model instead of a physical model, but if you have done it, you can do everything. You can make a model if you want by 3D print, or you can simulate and calculate everything on this digital twin. So very, very nice to see what happens. You can see Centre Pompidou, this was the first visualization, and everything didn't work here properly, and here is the end of this. And we did these calculations, we did everything on the digital twin before we built this like this. Elephant House in Zurich is as well an interesting thing, because these are Asian elephants, so they are used to live in the forest. So that's why this roof is open, like underneath the trees, something. So let's jump to Norway. This is I-Park from architects Helen and Hart in Stavanger. Also a very, very nice construction. Also, before we built it, because here you can see there are different challenges to get there. A very nice construction before done in a BIM model. Or also our skier during the World Championship in St. Moritz, here as well, we not just we don't just do the construction itself, but also the whole logistics, the packages, everything we do first on the digital model, on the digital twin, before we do anything physically. All we do is a question of the level of detail, and the level of detail has got 3 three different levels: the level of development, the level of geometry, and the level of information. And this is a very important thing. Also, if we talk about BIM, which level do we talk about? To coordinate the whole BIM process, we normally use a BIM manager. But this is something difficult because, for example, architects, they don't want the BIM manager. They think the BIM manager is trying to cut their designs or something. So we think that in future the BIM manager is not a person, it is a role of everybody that to coordinate technology and people and processes and standards. So if we do BIM, we don't just have a 3D model, we have everything which we have to calculate or we have to simulate on these buildings. We do online, we do it directly. To understand each other, we have a special language. So not even this digital language or digital, let's say digital Esperanto. It's a language that everybody understands, and this language is a IFC, Industry Foundation class, and therefore we are trying in the whole planning team to define what we are talking about, to define as we say, information delivery manual, IDM, to define which parameters we want to talk about in our windows, in our stairs, in our walls, and everything. And we should keep those parameters as simple as possible. As simple as possible. Just the needed data we want to exchange and nothing else and nothing more. Important. BIM to field and field to BIM. This is the method how we can connect our model on the computer with the reality. So there are different kind of methods, like for example the photogrammetry, where you can work with photos. Also these handheld distance meters, you have to look at, for example, this blue button. This is a very important button because you can blow everything into a Excel sheet or into a CAD system or whatever. So the danger to make mistakes by not seeing it because of the sun or something is gone if you have this Bluetooth connection directly into a system. Scanning is something not so easy. It's quite tricky, especially if you want to go around the whole building, inside the building, on different stories. So these connecting points is not so easy to handle them. So this is nothing for our carpenters. It's too complicated in this, and it's too expensive also, the whole equipment. But the result is impressive. The result is impressive. But if you look, for example, at this steel beam here, you have 1 million of points which are not necessary. So you should look for another method. For example, this total station method is something much easier to handle, because you can, as we can see, it's something I did with my students. You can also measure old buildings. It's no problem. And as you can see here, you are directly connected. It is a system like, as we say, VisiVic. What you see is what you get. So you can measure here, point, and you can see the CAD system directly draws this line, this point, this vector, these elements, this whatever. And You cannot make a mistake because, for example, if you have a raindrop exactly here where you are measuring, then it can be that your line blows to somewhere and you can immediately see it on your CAD system. That must be a mistake. So these systems are very, very common. They are very, very simple in handling, and every carpenter can do this. And the opposite of this measurement is a stake out. As we say, stake out. So you blow the whole points, all the points from your CAD system directly over this total station on site with a absolute precision. Here we are talking about 1 angle second. 1 angle second. That means in about 100 meters you are in a precision of 3 millimeters. So very, 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 very precise. And for especially for buildings like you see here in Bubicon, round facades and different stories, it's quite tricky. What can we say about CAD/CAM in this BIM process? If I'm asking my students what is a house for you, it can be that he says looks like this, very simple. So can also be that the houses are very complicated, and this building is quite old. You can see 1886 already done by this computer. It was smaller than my handy display, couldn't do nothing, and we tried to calculate this construction directly with the machine data, the CNC data, and what else. But we have also not just the complicated architectures, but only this movement back to simplicity. These houses are just wooden houses, no other materials, instead of glass, no other materials than wood. And also this one can be a very complicated or a very, how shall I say, a very, very designed strategy of producing these walls just in wood. Even the nails are in wood. These are beech nails, as you can see. You can drive them by automatic pistols, and in detail you have another interesting effect. On the right side you can see there is an effect of welding, wood welding. You know, you can weld wood if you glue them. No, if you don't glue them, if you just put them together. It's a very interesting kind of construction. Very simple, but very much BIM, because you have to drive all these CNC centers and you have to drive all these works. So let's jump to wheel. That's Omega. Omega, you know, the Omega watches, and this is a watch manufacturing, and you can see through the glass facade it's a construction just stuck together. No nails, no screws, no nothing. That was the wish of the architect, and the architect is here, Shigeru Ban, the Japanese architect Shigeru Ban. And here, what was the main challenge at this Omega building was the vibration. The vibration is something for us in the wooden construction. It's quite difficult to get there. So we are trying again on the digital twin, we try to get those vibrations done or properly built. Close to this Omega building is the Swatch building. The Swatch building is one of the most complicated building ever built in wood, because it's not just a construction in wood, it's also the whole installation. The whole MEP is integrated into this roof. This pictures are pretty new. You can see them if you're living in Biel and walking around. And here you can see before we built that building, the company had to make a mock-up where you can simulate. Again, you have a digital twin, you simulate there everything, and then you have a mock-up to simulate it in physically, in reality, and then you can build it. So, what are we doing with our students? We are trying to get as close to what we want, but in a easy way. This is a single house. It is in Switzerland. We don't have a lot of land, a lot of space, so we are reducing to the max. Reducing to the max means sufficiency. Sufficiency means each person has in about the 30 square meters space in his flat, and these modules, these autark modules are really interesting. This can be something for a researcher, can be a living room, can be an Alp room, can be a protection room up in the mountains, whatever. And the easy thing is that you can get at the moment you are needed, especially for let's say for a sport event, you can put there as much hotel rooms as needed in a very short time. This is everything is prefabricated. So as we see, I don't know if it works. Let's see if it works. No, it doesn't work. Can you start the video? Can you click? Can you start this video? You have to, No. If not, we leave it. Here, there's something else. There was the second video. What is the problem of our flats? They are not made for generations. For example, I'm living with my girlfriend inside there. I don't need a lot of space. Then we have children. We need more space. Then we have this ugly aunt living in our house. There will be no more space. And then children are away. We have less space. We have a Porsche. So it's something what we are trying in Switzerland, because Switzerland is so small. We are trying to get architectures to that point that our houses are able to handle more generations. So not moving as we are moving in our families. This is Bever Lodge. It's a hotel. And it's totally, we close it totally in our BIM process. This is our reference model. As you can see where it begins very simple with these blocks, with these rooms, and up on the roof. And in this state you can make a lot of simulations. For example, fire, sound, costs, everything you can do on this level of rooms or spaces. And you have also in the background, of course, everything is done, everything is inside here. But how shall we find the right place, the right piece on the right place? We are using modern things like these virtual reality. You know, in a modern CAD system, you can, with one button, you have these data for this file exchange for these glasses. But the better way is not virtual reality, it's augmented reality. Augmented reality means you have the reality and you have something information additional, like these Google glasses. And now, what is the aim of this? When I learned carpenter, when I got carpenter, we wrote by hand numbers on our wooden pieces, and then we had etiquettes with barcode, and then we had a QR code. And what next? Next would be a chip, a data tracker, like for example this LoRa. LoRa means low range system, and in Switzerland all it's another story. All our dogs and cats, they must be chipped. So you can read out who is the owner of this dog. So we could chip our wood as well, our wooden pieces as well. So if, for example, this Franz, his name is Franz, is standing in front of this beam, and you can see it's quite a tricky beam because he was wet overnight. No. But you cannot see what is the end, what is the beginning, what is up, what is down. How shall we? And if he had Google glasses and we have a chip inside this beam, he would know exactly where to put it. And if it's done, if it's there, it could give me further information. For example, about the strength, about the humidity, about temperature, and whatever. So this funny bloody QR code is getting more intelligent by a chip, by a data tracker, and gives me more possibilities, not even on site, but also after, in the maintenance of our buildings, in our facility management. Very interesting. BIM and HVACS, again, we have our Beaver Lodge. It's an architectural model, it's a reference model, and we do everything on this reference model, normally produced by the architect. In the future, we don't know who will design. Design will come from the architects, but could be that there are new professions just having built these reference models. These reference models, as I said, the space models, the structural models to make all these earthquake simulations, these static simulations, everything like this, and the MEP, the mechanical, electrical, plumbing model as well. This is, probably this Swiss Army knife that was a huge success. This was the first Swiss Army handy. It wasn't that big success as it was, because you had to go by two. The stronger one had to carry the cable, and the other one had enough breath to talk, to telephone. So it wasn't that success. But after this, I bring this Nokia communicator. The elderly people know this Nokia communicator. It had in about 70 buttons. 70 buttons. A whole of complicated things. Every button is on rubber and whatever, complicated. And then Steve Jobs came with the first idea, the first iPhone. And there were no more buttons, just an intelligent surface. So no buttons, and everybody was laughing, especially Nokia was laughing, that cannot work, a phone without buttons. But if you look and if you think that one app is one button, so with an intelligent surface, you have at least 2,000 to 3,000 buttons without a wholly complicated construction behind. But what are we doing in our building industry? We are still in Switzerland. We are still on that level. In all our walls, we have a lot of wires. We have a lot of cables. We have everything. But that's gone. That's gone. We have to look for new ways. Let's see at a hotel room. This is a hotel room in which I'm playing with my students. And I get off gypsum board, insulation inside. As you can see, everything appears. The whole MEP is inside, is planned inside, because it's a prefabricated module. Everything has to be inside, and this is very, very complicated to get these data in this form. We are needing them. So we have to look for better ideas, for more intelligent ideas. Like we are in the same room, as you can see, in the same room, where we try to steer everything by a new system. For example, you know, different things. Also by IKEA, you can buy those things to not only to turn off and turn on the light, the whole ventilation, the heating system, the music. You can talk with this little thing, let's say little Amazon. It is called Echo, Amazon Echo. It's called Alexa. So you can talk with Alexa, and you can get everything from this Alexa, and you don't have any wires in your walls. Or this is another example. This is NeoBrain. I have 2 students in Silicon Valley by now, and they are trying to get these systems inside our building industry. What are we doing? What are we doing in Biel? Is it possible that we can learn BIM in a school? Yes, we can. Yes, we can. But we need digital references. We need reference objects, and we have to look at all these new challenges. Like, we have a new generation of people, a new generation with absolutely new skills and grades, and we have always this problem of financing, the politics and the generation change that we have to take care. And also, I mean, this is a part for me. I'm a carpenter, so this connection, technology and handcraft is something very, very important. Digital, you can get a master, bachelor or master degree in this wood technology, and in this wood technology, as you can see, we have 3 focal points, like multi-story timber construction, complex timber structures, and BIM. What is the main challenge of BIM? That our authorities, administrative offices, our governments, they are demanding BIM, but they are not able to handle a 3D model. They are still asking for 2D plans, as they did 100 years ago. So we could deliver them a BIM model, but they are not, authorities are not able to handle BIM models. That's one of the biggest challenges we have to handle in Switzerland. So in our research, we have 3 different scales. This is one, the material scale, the micro scale, the meso scale are the buildings, and the macro scale is the settlement, is this infrastructure, is urban development, all these things you can handle. And let me show you one example. We are tried in 3 theses. The idea was to reinforce wooden high-performance posts. Project was called Beach instead of concrete, and this is a typical thing of concrete. And as you can see, we are here reinforcing our posts. Reinforcing, that means we can weld them directly, and we have a fixed post inside. This is the group where we did that, and you can see this is a typical domain of concrete. Every post here carries 220 tons, because there is a crane, and there is a story with offices, and there is a story with apartments above. So quite a big construction. And as you can see here, these beach beams came out of students' work directly together with these industry partners. A very interesting thing. Here we are in the level of the offices in this, and above the apartments. So sometimes we are looking, we are finding the lighthouses of wooden constructions not where we're supposed to find them. This is up in Swiss Alps on Julia Pass. It's a theater. And people often ask me, are you able to build wooden construction, wooden houses which can resist the hurricane? Yes, of course, it's not an illusion. This is a hurricane. Here up in the mountain on 2,800 meters, we have wind speed of 300 kilometers per hour. So these houses, this theater is hurricane resisting. La Torre Babilonica. Okay, this is the last picture. I hope I could show you a few things. I could give you a few inspirations or ideas. Thank you very much.